Welcome to MathLink, where we're here to connect the dots. I am Mr. C, and I will be covering this particular unit, and we're going to talk about circles, the area of a circle, how to find the area of a segment, and also we're talking about the area of the sector of a circle. So let's get started. So to find the area of a circle is the equation A, which is area, equals pi r squared. Pi has a value of 3.14, and it can continue to go on, but we usually stop there. And then r is the radius, and then we just square the radius. So just to find, if you know the radius, you just multiply the radius. Square by 3.14, again, is r squared. Very quickly, let me just show you what we're talking about. So here's a circle, pretty good circle. And here's the radius. So here's our radius. And to find the area, you need to know the radius, how far it's from the center to the edge of the circle. And then we multiply by pi, which we, in your calculators, you can look at use pi, or we use 3.14. And that's it. That's all it is to find the area of the circle. And what do we mean by area of the circle? It's all what is shaded in green here. Sometimes they may give you the diameter, and if they give you the diameter of a circle, all you do is take half of that to figure out the radius. So this is our diameter of a circle, which is in blue, and just take half of that to give us the radius. So actually, let's look at a problem. It says find the area of a circle that has a 6.500 inches, or we can say 6.5 inches. And so let's set it up. Let's find the area of a circle. So a lot of times I like to draw the picture. Here's our circle, and here's the radius. It's right there, 6.5. In order to find the area, it would be A is equal to pi times 6.5 squared. So all we need to do is find 6.5, square it, and then multiply it by 5. And that would be our answer. Now, whenever you give area, don't forget, area is two-dimensional. So our answer would be squared. What I mean by answer, I'll show you in a second what we mean by that as we do this particular problem. So what we're going to do for this particular problem again, let's write down this is equal to, oops. Oh. This is equal to, A is equal to 3.14. And it's going to go further decimals or use the pi function on your calculator times, and we square 6.5. I think that's about like 42.25. We multiply those two numbers, we get an approximation. Again, everything's approximation, like 132.7. Always write your units, square inches. So that would be our answer for this problem, how to find the area of a triangle. Now, what we want to do now is find the area of a sector, a part of the triangle, a sector of a circle, excuse me, not triangle, but a circle, excuse me, guys, is a figure formed by two radii. And the arc that intersect by the radii, that's called a sector. So let me draw a picture of that and then give you the complete formula. Now you see partly the formula on here. That is not all of it. And I did that on purpose so you can memorize this formula. So here's our circle. Let's draw a circle. And what do we mean by a sector? Here's our center. Let's say we have a radius right here and another radius, and we call them radii. And let's say we just want to find the green area. We don't want to find the whole area of a circle. So we don't want to find the whole area of a circle. We're talking about, in this case, the sector of a circle. Now, I'm going to draw something else, guys. If you notice, who noticed this? That in this sector, I only want to find that green area, excuse me, we have theta angle. We normally name this angle as theta, okay? So this theta, we can see is greater than 90 degrees and less than 180, so it's an obtuse angle. So you need to know theta in order to solve for the area of a sector. So to the formula. So how do you find the area of something that is in the green area of this drawing? So A is equal to, so write this down, A stands for area. Area is equal to whatever the is, that's theta, divided by 360 times pi times r squared. Now notice that pi times r squared, we just talked about that. That's the area of the circle. And so basically what we're doing, we're finding the area of the circle and we're dividing it or we're multiplying it by a small sector of it to give us the area of the sector. So that's basically the concept. So that's the formula you want to use to find the area of a sector. So let's look at an example of the areas of sectors. An apartment balcony is designed in the shape of a sector. That's an interesting shape. The balcony has a center angle, that center angle of 225 degrees, excuse me, and contains 24 square meters of surface area. Find the radius. In this case, we want to find the radius of a sector. So the first thing I'm going to do is draw this balcony. So let's try to see how this looks, this balcony, what it looks like. So we have an angle, let's say 225. So the angle is going to look more like this. I'm going to do it like this, guys. Let me draw a circle. Here's my center. Here's this line. And let's say 225 is about here. So what I'm saying is this piece here, this is my angle, and that's my 225. And I really want to find this, guys. I want to find, it gives me the area here, which is in green. Now it tells us that our area, our surface area, and notice surface area is in square meters. In this case, our surface area is 24.0. We know that our angle is 225. We want to find what is the radius. We want to find the radius. What is So that's our drawing. And in our case, let me just set this up. We know the formula is A is equal to, and that's theta. Theta represents angle. 360 times pi times r squared. Now, what's given to us? What's given to us is our area, surface area, which is 24 square meters. So that must be A because it's in square meters again. We got 225 as an angle, our central angle, divided by 360. I'm actually going to write this down. This is 3.14. We know what pi is, and our r squared is unknown. And we're just going to do a little algebra to solve for r. And that's the setup for this particular problem. So let's go to our whiteboard and do the work and get our answer for r. So here's our problem on the whiteboard that we did before. Again, we substituted pi for 3.14. So one of the first things I would do is do 225 divided by 360, figure out what that is, and then multiply it by pi. So let's actually do that. And so this gives us 24 is equal to, and so I'm going to give you an approximation, probably like 1.9 4.963. And this approximation times r squared. So I simplify what I underline or bracket in red. Now the next thing I'm going to do, I'm going to say 24 divided by 1.963 equal to r squared. And I'm going to put down r squared is approximately equal to, once I do that division, I think it's like, let me see, we got like 2, it's close to 2, so it'll be like 12.223 meters square. Again, everything is still in meters square. Now the problem is we do not have r by itself. We have r squared. And so to get r by itself, we just take the positive square root on both sides of the equation. In that case, we end up with r. This gives me r, again, is approximation, excuse my approximation signs, is 3.49 meter. Now, it's not meter square, it's meter. And then if we want to round that off, r is equal to, let's say, 3.5 meters. And then that's your radius for that particular problem that we just did. The last concept we're going to talk about is areas. Now, a segment of a circle is a figure formed by an arc and the chord joining the end points of the arc as shown by the figure below. The area of the, again, this is segment, is found by subtracting the area of the triangle from the area of the sector. So let's look at what we're talking about. We have a circle, and what you notice here, guys, is that we have, oops, excuse me, I put it in black, but let's bring it back up. We have a circle, and what I'm lining in green, that is called, remember what that is called? That is called a sector. All of that is a sector. So in order to find the segment, which is only the blue color or the blue color, I have to find the area of the sector minus the area of a right triangle and the area of the triangle. The triangle's in white, excuse me. I'll get my words correct in a second. And then that will give us the blue area. So there's basically 4 steps you need to do in order to find the area of a segment. Again, the segment is what's in blue, but we have to use our sector in order to find the area of a segment. Okay, so let's clear all that. So let me go show you an example, and we'll go step by step how we can do this. So here's an example. We have a segment A, C, B. Notice where A, C, and B is. We want to find the area of that segment given these parameters that we have on this drawing. Okay. What we see here, we have a central angle of 140 degrees. We will use that later on when we want to find the area of a sector. We did that earlier. We also have a radius. Here's our radius. Our radius is 4.50. What we want to find is this area that's in blue. Now, actually, I'm coloring it now in blue and green, but that's what we want to find, the area of what's in blue. So there's 3 steps. We first got to find the area of the sector. We've got to find the area of the triangle, and then subtract the area of the sector minus the triangle will give me that blue area, just a segment. So let's get started. We're going to do this on a whiteboard, and we're going to go in different steps. So let's redraw this shape on the whiteboard and see how we can do this. Now, as we go to our whiteboard, I'm going to give you an answer before we go on our whiteboard, so we have some room to show you some things. Let's first find the area of the sector. Okay. Now the sector, let me highlight again what that would be this piece here, all of this that I'm shading in. Now we've done examples of that earlier. So let's actually do that with this particular problem. And then we'll take that answer again. Like I said, we're gonna go to our whiteboard and put that on the board and then show the remaining steps. So this would be step one. So here's one. I'm gonna put down 1. And so the area of a sector is A is equal to the 360 times pi times r squared. Now we know our angle is 140, is that correct? Divided by 360 times pi, which is 3.14. And our radius is on there. It is 4.5, again, square. Now you go ahead and do this on your calculator. If you want to pause the video, do the division, then multiply those numbers. And don't forget you're doing 4.5 square. So we've done this before. So let's do this. And so what we should end up with is an approximation of 24.740. That is our area of the sector. So let's remember that number, because we're going to carry this answer to our whiteboard, and that's going to help us find our final answer. So we carry our 24.748, underlining green, and we're going to use that number to help us to find our answer. And we're going to minus some other number, which is a triangle. I don't know what it is yet. We're going to find it. And I also drew the picture. Now notice the radii are 4.5, or the radius is 4.5. And also in the drawing, it says the height of this triangle is 1.5. Now, if you notice the triangle, we normally look at it as like upside down. It's an isosceles triangle. How many notice that? Because we got 4.5 on both of the sides. The base, which is actually up, we don't know that. But once we find that base, we can figure out the area of a triangle. Now, the formula for the area of a triangle, we'll get to that later, but let's figure out what that base length is. Now, what we notice here, I'm going to circle this in green. Well, let's take one of the triangles. I'm going to put this, again, upside down, keep it like it is. This looks like this. And so this is 1.5 and 4.5. Now the 4.5 looks like the hypotenuse, and we have one of the legs. I'll call it B, and then we have an unknown B, and then we have 1.5 as the other leg. So what I'm going to do is figure out what B is. You're going to see why I'm figuring out what B is in a second. So that B corresponds to right here. So what we're going to do is Pythagorean theorem to figure out what B is. And so what we end up, let's show the work. B squared, and it's really A squared plus B squared. So let me write it this way. So it'll be 1.5 squared. That's our A squared plus B squared equals C squared. That's Pythagorean theorem to help us find the sides of a right triangle. So A squared plus B squared equals C squared, our hypotenuse square. Okay. So once we do this, this is 2.376 plus B squared is equal to, in our case, we're looking at about 20.25. And we're just showing the work here. So B squared is equal to, all I'm doing is going to subtract 2.37, and make sure I wrote that number out, 6 on both sides. So I'm just showing a little bit of the work. So B squared would be like 17.87. I think that's like 84, I believe, guys. And the square root on both sides. And so B is equal to, if you take the square root, it's approximately, I just use approximation sign, guys, 4.228. Now I'm going to just underline my answer, overall answer of the, but that will help me get my answer. So everybody look at that. So 4.228 is half of that base of that isosceles triangle. That's what B is. So how long is it from this end to that end? From the orange end on the triangle. It would be twice as long. In our case, it will be 8.456. So this is 8.456, that orange line. Now, what I'm going to do, we'll come back to this page in a minute to get the answer, okay? What I'm going to do is I'm going to go to another page, a clear page, and continue with this triangle. So this would be like step 3 in our case. So I'm gonna put down 3 because we have the triangle. Let me rewrite it now a little bit bigger, where this is 4.5, and it's not up to scale, but it gives you an idea of what we're looking at. And this was 8 point, what do we say? 8.456, I think. So, and then don't forget, I'm gonna put this in red. What else was given to us was that line was 1.5 in red. There we go. Now the bases face up. Remember, the bases face up. I could rewrote it and rewrite the triangle as we normally like to see the base on the bottom. But again, we want to find the area of a triangle. And we know our formula from past videos and other, that area is equal to 1/2 base times the height. That's the area of a triangle. We have the triangle. We have 1/2. We know the base is 8.456, I believe. And the height is actually 1.5. It goes from the vertex to the base. Again, this is isosceles triangle. Now let's do the math for this. And once we do the math for this, we end up with approximation. So go ahead and do this on your calculator. You should end up with approximation of what? 6.511. And so that's the area of the triangle, 6.511. Again, I'm just going to underline that and put a check. So go ahead and try it on your own and make sure you got that number. You want to pause the video. Now let's go back to our first page. And so we know the area of the triangle. That's, I want to put on the underline this green. We said it was 6.511. So what I'm going to ask you to do is subtract 24, which is that sector minus the triangle. It'll give me just what I'm going to highlight in blue. So it'll give me this piece here. This is the blue piece. So I'm going to write my answer in blue. So once you do that, we end up with a approximation of, I think, what, 18, what you get, like 18.2. And we'll leave that for right now, 18.2. And we'll talk about, in our case, we're talking about units square. So make sure you write that down, square units. So if this is in meters, this would be meters square. So make sure you write your units in squares since it's area. And then that'll be our final answer, 18.2. Again, I hope this helped how to find the area of a circle, and then also the area of a sector of a circle, and then the area of a segment of a circle. Again, you want to review this video if you still have questions, and also look at some of our resources that we have on our MathLink website. Again, MathLink is about bringing it together. And again, thank you for watching this video.